Welcome to the Explainer. Today, we're going to talk about the single most important idea that makes modern AI, well, smart. It's all about its ability to handle uncertainty. Because, true intelligence isn't about knowing everything for sure, it's about making the best possible guess.
So let's just start with a puzzle. How can a self-driving car possibly navigate a road it can't even see perfectly? Well, the answer isn't some kind of superhuman vision. It's all about calculating the odds. The car is constantly asking itself, okay, what is probably there? And the answer to that question, that's the key to all of modern AI.
I mean, let's face it, the real world is messy. It's not some clean, logical system of ones and zeros. It is absolutely filled with incomplete information, noisy data, and, well, just ambiguous situations. So to make smart decisions in this kind of environment, an AI can't use simple yes or no logic. It has to learn how to navigate the world of maybes. Okay, let's take medical diagnosis, for example. A cough could mean a cold, sure, but it could also be allergies or something else entirely. And a lab test, not always 100% accurate. A probabilistic AI gets this. It gives a doctor a percentage, a likelihood, instead of a definite and maybe wrong answer.
And yeah, let's get back to that self-driving car. In the rain or fog, its sensors are just flooded with noisy data. That blurry thing up ahead, is that a person or is it just a weird shadow from a tree? The AI can't be totally certain, so it has to calculate the probability of each scenario and act on the one that keeps everyone safe.
And you know what? You use this tech literally every single day. When you talk to a voice assistant in a noisy cafe, it has to figure out what you meant to say. Did you ask about the weather, or did you say the word weather? The system figures out the probability of each option based on the context to make its best guess.
You see, this is a huge shift in how we build intelligent systems. Early AI, the logic-based kind, it worked with these really rigid rules. If X is true, then Y must be true. But we all know that's not how the world works, right? A penguin is a bird, but it doesn't fly. Probabilistic AI is way more flexible. It looks at the evidence and says, there's a high probability this is a bird. Which, let's be honest, is a much more realistic and useful way of looking at things.
So this whole approach, it's got a name. Probabilistic reasoning. It's really the engine that lets an AI operate in all those shades of gray we find in the real world. At its core, it's about a simple but really powerful idea. You quantify what you believe, and then, and this is the important part, you update that belief when new information comes in.
A core tool for this is something called conditional probability. Now, I know, it sounds super technical, but the idea itself is incredibly simple. It's just a way of asking, how does a new piece of info change what I already think is true? If we see someone coughing, the probability they have a cold, well, it goes up. Conditional probability just gives us the math to make that gut feeling official.
Okay, but that brings up a really big question. If everything is connected, symptoms to diseases, sensor readings to objects, how on earth does an AI keep track of all these interconnected probabilities without its digital brain just, melting down?
Well, the answer is this really elegant tool for organizing all that uncertainty. It's called a Bayesian network. Honestly, the best way to think about it is like a map, a chart that shows an AI the relationship between cause and effect, letting it see how everything influences everything else.
And this map is surprisingly simple. It's really just made of two things. First, you've got nodes. These are just the concepts or variables we care about, like a specific disease or a symptom. And then you have edges, which are just arrows that connect the nodes and show the direction of influence. Simple as that.
So if we go back to our medical example, the map is super direct. We just draw an arrow from the disease node to the symptom node. This little drawing visually represents something we already know intuitively. Having the disease makes it more probable you'll see the symptom.
Now, this quote here, it reveals the secret genius of this whole approach. Joint probability is just a fancy way of saying the chance of everything happening at once. What this quote is really saying is that instead of trying to solve that one giant, impossible calculation, the AI can just focus on the little local pieces, those simple one-to-one relationships. This structure is what lets it break the problem down.
And that right there is the magic of Bayesian networks. They turn one massive, totally overwhelming problem into a whole series of small, manageable ones. The AI just needs to figure out the local connections, like how a disease affects a symptom, and then it can chain all those simple probabilities together to understand the entire complex system. It's brilliant.
And look, this isn't just some abstract theory, right? This probabilistic way of thinking is the driving force behind technology you interact with every single day.
let's take a look at how it makes smarter decisions out there in the real world.
This is exactly how those autonomous cars do what they do. They're constantly building and updating a probabilistic map of the world around them, calculating the likelihood of what other cars will do and what the safest path is, all in a fraction of a second.
Or think about your spam filter. This is exactly what's going on under the hood. Every time you mark an email as spam, you're actually training the filter. You're helping it update its probabilities. It learns that, hey, these certain words make an email way more likely to be junk, and it just gets smarter with every email it sees.
And this brings our medical example full circle. AI diagnostic tools, they don't replace doctors, they empower them. They can sift through thousands of data points in a patient's history and present a list of possible diagnoses, each with a calculated probability, acting as this incredibly powerful decision support tool.
And finally, think about Netflix or Amazon. Their recommendation engines, they don't know you, but they analyze your behavior to calculate the probability that you'll enjoy a new movie, all based on the habits of millions of other people who have similar tastes.
So, what's the big takeaway here? It's this. The ability to reason with uncertainty is what elevates AI from just being a fancy calculator, stuck with rigid rules, into a flexible, intelligent partner that can help us navigate the crazy complexity of the real world.
Which leaves us with one final, kind of provocative thought. As AI gets better and better at mastering the maybes of our world, in medicine, in finance, even in law, the real challenge for us becomes, what decisions are we willing to trust to the art of the calculated guess?